Okay, let's start do the demo. The first one is a right turn. Here I am logged into the Pi. So here I have the code. So let me open this. Now I'm going into the Python console and I have all my codes in utils and I'll import it first. So before I do that, let me just do a very quick walkthrough of the code. So here it is. It's all in the utils script. So the left is uh, nothing but you set the pin in the GPIO for 11, 15, 16, and 18 uh, as false, true, true, and false. So what you will do is that's for reverse. For going to right, what you do is you have to control the motors in such a way that uh, only the right set of tires move in the forward direction, and to go to the left, go to the right, you do it in the opposite way. So this is essentially what you do. You just control the voltage across those pins and set it to low, and that's how we control the direction of the motors. Now I have those functions already here in the code that I shown before. Now, if I do a go right, let's see, go right. I do since I have kept the robot on top of a Lego box, so it won't jump off. So I can just say 0.5. So it should not. So before I do that, I do an init to clear everything. So the forward 0.5. Okay, as you can see the tire, you can see the direction forward, which we saw last week. It will move all the tires. Now, if I do go right, 0.6, it should rotate the left side tires, uh, both the left side tires in the forward direction. So that's how you steer it towards the right direction. So yeah, that works. So let me try go left. So it should do in the opposite way. Great. Now the pivot left is nothing. If you want to do a pivot movement, that's how you do that. So what you do is if you want to pivot to the left side, what you do is you move the left side tires in the opposite direction, in the reverse direction. So pivot left 0.5. That's good. And the pivot right, it's in the same thing, but the right side tires should be in the opposite direction. So that's good. So we did the demo for, let's see, where are we? Okay, now here let's do the distance sensor. So I'll walk through the distance sensor here. So the distance sensor demo is that I need to keep something in front of the sensor to make sure it works. Actually, I'm drinking a cup of coffee, so I'll put the coffee cup in front of So here you can see that. Okay. Oh, okay, here. So it should be probably like 15, I guess it's 15 centimeters. Let's see what it gives. Now, distance function, so 11.5, okay. Should be correct. I was just taking a wild guess. So 11.5 or 12 centimeters. So that is working. So that's all for today. So the next my next project, I'll be trying to write something to do some coding for autonomous uh, autonomous driving. Uh, so I don't want to use my keyboard. So I just want to the ultimate goal is for me doing this project is to test the AI algorithms in computer vision. So that's why I have a camera. If you have seen the robot, I have a Pi camera on top of that. So there's like really a lot of cool things that we can do using OpenCV and a ton of other things. So there are, if in case if you're trying these things, I have had a few challenges with related to latency. This one of the problems when writing code using Python is latency, because you don't expect uh, so if you're doing some autonomous projects where the car is driving by itself, you need to be have very real time response or very minimal latency. So that is one challenging aspect. So you might end up doing coding in some low level programming languages like C, C++, and so on. But Python, it might be possible, but for a prototype. But those are some of the interesting challenges that you might get. Okay, so we will see all those exciting things in the next week and the coming weeks. So till now, till that time, uh, I'll be working on those. But then all these codes that I've been doing, I have posted it in GitHub, and it's available there for checking or for using.